All right, hello, welcome to Physics Essentials video 3.1. We're going to be learning about linear motion, is really the name of the whole unit, and then specifically we're going to focus a little bit more on projectiles today. Before I get too far into this, I should also apologize. I am fighting off a terrible cold, so I may be a little bit sniffly, which I know is a little bit gross when it's recorded, so I apologize for my sniffling. So here we go, objectives. By the end of this video, you should be able to do these three things. You should be able to distinguish between and identify the 4 types of motion outlined here in the video. Secondly, when we're done with that, you should be able to explain what a projectile is and give some examples. And thirdly, you should be able to understand and apply the 2 rules of projectiles. Okay, so here we go. 4 types of motion. The state of Michigan, which has outlined the curriculum for this class, has broken motion up into 4 types. The first type is one-dimensional motion. This is pretty much what we've been doing up until now, all the motion we've talked about. In one-dimensional motion, the object is free to move in one dimension. All right, so it might be that the object is free to move on some sort of horizontal axis or some sort of vertical axis, okay? Or maybe even, maybe it's on a ramp or something, and so it's on a slanty axis. But basically, if it's in one-dimensional motion, the object can only move in 2 directions. It can either go forwards or backwards, right? Like if you're talking about a car on a road, this car can go forwards or backwards, one dimension. Or if you're talking about throwing a ball up in the air, the ball can go up or down. Or if you're talking about a cart on a ramp, the cart can go up the ramp or down the ramp, right? So those are all examples of one-dimensional motion. It's one line, okay? Sometimes people get confused about that if it's one dimension, why can it move in 2 directions, okay? One dimension means it's a straight line. It points in 2 directions, and so you can go either of those 2 directions. So examples of one-dimensional motion would include, I just mentioned these, a car driving on a straight road or a ball that's thrown straight up into the air. Notice, if an object is moving on a straight line, the only way it can turn is to completely turn around and go the opposite way, right? This car here, if it's driving this way and it's limited to one-dimensional motion, the only way it can turn is to go back, okay? As soon as the car is driving this way and then turns that way, it's no longer one-dimensional motion because now you've got 2 dimensions, okay? Which brings us perfectly into the second type of motion, which is 2-dimensional motion. Now the object is free to move in 2 dimensions. So 2 dimensions means that you're going to have kind of an X direction and a Y direction like you would in math class, right? So your object could theoretically drive this way and then turn, okay? So examples of 2-dimensional motion would be a car on a curvy road, right? That's 2-dimensional motion. A ball being thrown up into the air, right? So you've got your dude, hello. Okay, the ball is traveling in 2 dimensions. It's not just traveling along a straight line. Okay, so in 2-dimensional motion, the object does not necessarily have to move in a straight line, and it can turn in any direction, right? A bird could swoop down and pick up this ball and carry it this way, and then this way or whatever. So as long as it's not going in a straight line, that is 2-dimensional motion. Okay, so the next type of motion we're going to talk about is called periodic motion. In periodic motion, the object is going to repeat the same motion over and over again at regular time intervals. All right. Examples of this would be a pendulum. Okay. The idea is a pendulum is this. It's a weight at the end of a string, and when you release it, the pendulum goes back and forth, back and forth, back and forth, back and forth. That's periodic motion because it's repeating the same motion at regular time intervals. Okay. Another example is if you take a spring and then hang a weight from it. If you stretch the spring out and then let it go, the spring will bounce up and down, up and down, up and down, up and down. Okay, so that's another example of periodic motion. Okay, so periodic motion is motion where the object repeats the same motion over and over again. All right. I should probably comment that notice also the pendulum is also 2-dimensional motion, right? Because it's traveling in a path that's not a straight line. But by describing it as periodic, we're being a little bit more specific and descriptive. So if I give you an example of an object and say what kind of motion is it, you want to give the type that is most descriptive, okay? The one that's most specific. And these are currently arranged in the video in order from least descriptive to most descriptive. So one descriptive, or one dimension, two dimension, periodic, and then the third one is circular motion, which is pretty self-explanatory. It's an object traveling in a circular path. So examples would be a car driving around a circular path, the Earth orbiting the sun, or the toy at the end of a rope or a string or something. So if you imagine, letting a yo-yo drop to the end of the rope and then just whirling it around and around and around, then it's traveling in a circular path. Okay, a kid sitting on a merry-go-round would be another really good example, right? If you're sitting on a merry-go-round, you go around and around in a circle. All right. Notice anything that's circular motion is also periodic and two-dimensional, but again, by describing it as circular, we're being more specific. Okay. So there you go. There are your 4 types of motion. I always think it's weird that they didn't include 3-dimensional motion, but whatever. That's cool. So here we go. There are your 4 types of motion. Okay.